As the gap between farmer and consumer shrinks around the world, we must continually adapt our methods to meet the ever-increasing demand for safe, high-quality food. Dr. Richard Murphy is the Director of Research of Alltech European Biosciences Center in Dunboyne, Ireland. How are you, Dr. Richard Murphy?
I'm very well, and you?
Very well. Thank you for this time. Globally, it well understood that there is not silver bullet to replace antibiotic use in animal production, and poultry producers will need to focus on making incremental improvements to overcome this challenge. Why worry about antibiotic resources resistance?
Yeah, that's a great question, and we can talk at length on it. I think the issue lies in the high level of resistance among pathogens that would have food safety implications. So E. coli, Salmonella, Campylobacter, for instance. You can get quite a lot of information each year from bodies like DANMAP, EFSA, or NARMS here in the US, and certainly the occurrence and the frequency of antimicrobial resistance is still very, very high. And that's regardless of the restrictions and regardless of the reduction in antibiotic use that have been made globally in both poultry and in livestock production systems. So I think the knowledge that we have now is that antimicrobial resistance is a persistent issue, and simply restricting or removing antibiotics is not necessarily going to solve the problem of antimicrobial resistance among these food safety pathogens. I think when we look at the work that we've carried out in Dunboyne, so the research team in Dunboyne is very much focused on trying to understand how we can use nutritional strategies as a way of influencing the makeup of the gut microflora. And what we found is actually quite interesting in that when we utilize prebiotics, so mannan-rich fraction-based prebiotics, from Saccharomyces yeast, you can actually have a great impact on the diversity of the gut microflora. So the richness, the extent and range and type of species that are present within the GI tract increases. And that's a particularly important way in which we can begin to control or restrict pathogens within the GI tract. So this concept of what's known as colonization resistance, whereby when you increase the diversity of the gut microflora, it enables the GI tract to self-police, so it can begin to control and restrict the colonization of the cecum and other regions of the GI tract with pathogens like E. coli, like Campylobacter, and like Salmonella. And when we think about the issue that we face with antimicrobial resistance, if we can restrict the presence of those pathogens that are resistant, then we can get greater control in antimicrobial resistance. So it goes well, I think, in tandem with the move towards antibiotic-free, the move towards no antibiotic ever in poultry and livestock diets. This concept that by controlling the pathogens, we will begin to control the resistant pathogens that are amongst those as well.
Great. Where we are now with restrictions of antibiotics?
So they're becoming increasingly restricted in their use. It's becoming, I guess, clearer to regulatory bodies worldwide that they do need to police this to a greater extent. And certainly within the EU, we've seen moves by individual member states within the EU and in a concerted effort to restrict the use of antibiotics. And I think in many respects in credit to the industry, certainly among poultry and swine producers, there has been a move towards reductions in antibiotic use and an increase in no antibiotic ever production and in antibiotic-free production systems, regardless of the regulatory frameworks that are put in place by individual countries. So the industry itself has been extremely proactive in this regard in moving towards reducing the reliance on antibiotics and reducing their use of antibiotics. At the same time, industry is searching for solutions. Industry is looking for ways in which they can increase their, or rather reduce their use of antibiotics, but increase the health and performance of their poultry and livestock. So the industry has been extremely proactive in this regard in tandem with regulatory bodies worldwide.
What is the long-term outlook for antibiotic use in agriculture?
I would see increasingly less and less use of antibiotics. It is still quite high. Certainly within the EU, it varies from member state to member state. There are differences then between use in Europe and use in North America and Canada, for instance. But I do think that in the next 5 to 10 years, you will see less and less antibiotics used and ever increasing antibiotic-free production systems in poultry, in swine and in livestock. It's something that the industry recognises that they need to do. So the issue of antimicrobial resistance among pathogens that have food safety implications is extremely high, and certainly taking steps to control those pathogens will enable a reduction in antimicrobial resistance, I do believe.
Did you see the same scenario in Latin America?
Yeah, there are increasing antibiotic-free production systems in Latin America. I do think the consumer is the key to this. The consumer is looking for antibiotic-free or meat raised without antibiotics, antibiotic-free production system. So consumer is king. If the consumer is pushing for this, then producers will have to certainly facilitate that and certainly accommodate that. Those producers that adopt and move towards antibiotic-free production systems more quickly or are at the forefront of it, they're certainly the ones that will benefit the greatest, I think.
What alternatives are there for antibiotics?
Quite a lot of work on this area. Within Alltech, we certainly focus on many different aspects of it, but I think one of the key tools that we have are the use of manna-enriched fractions, so prebiotics from Saccharomyces-based yeast. And these, I think, are probably better regarded as second-generation prebiotics. So originally, there were many different first-generation MOS-type products. These were just generic mannan oligosaccharide preparations. We subsequently developed a second generation, so highly enriched manna-enriched fraction. And that is a product which has a really good and a really strong benefit with regard to increasing the diversity of the gut microflora. And we see it across species. It's not just poultry, but in swine. We've done some ruminant studies of late which basically show it's multi-species. We increase the diversity of the gut microflora, and that allows for a restriction, if you like, of the growth of pathogens. In tandem with that, one of the major, I guess, modes of action of prebiotics like manna-enriched fraction is that they can agglutinate type 1 fimbriated pathogens like E. coli and Salmonella. So these are bacterial pathogens that have appendages on their outer cell wall, and they use those to adhere to mannan sugars on the surface of the intestine, and that's how they colonize and proliferate within the GI tract. But instead, when you have manna-enriched fraction present, that acts like a decoy. So it binds to the bacteria and stops them from colonizing the GI tract. And when you reduce their colonization capabilities, you decrease the load of E. coli, of Salmonella within the GI tract, and obviously that decreases the resistant E. coli and Salmonella as well. So that's really the power of a manna-enriched fraction. Something that we have noted more recently is that we're not just limited to controlling E. coli and Salmonella. And this is one of the additional benefits of that concept of colonization resistance, whereby when you increase the diversity of the gut microflora, you make it less hospitable for other pathogens like Campylobacter, for instance, Listeria, Shigella, Helicobacter. These are bacterial pathogens with food safety implications that we have seen impacts on their prevalence within the GI tract when we have manna-enriched fraction present in the diet. And I'm particularly excited by this because it really allows us, I think, to control multiple pathogens, not just E. coli, not just Salmonella, but others that have significant food safety implications like Campylobacter. And again, these are organisms that have high presence and high prevalence of antimicrobial resistance among them. So it's a really good benefit, I think.
Dr. Richard Murphy, thank you very much for your time.
Thank you.